So today on IoT Innovation, we've been talking about how we build all these things. Now we have to actually make something. We're now going to consider how the maker movement and manufacturing is impacting IoT.
This episode of IoT Innovation is sponsored by Anritsu.
Telecom Careers, the #1 global telecom and wireless job board. telecomcareers.com.
Welcome back to IoT Innovation. Today my guest is Rob Bodor from Proto Labs. And Rob is VP and General Manager of Proto Labs for the Americas. And what we'd like to talk about today is understanding a little bit more about Proto Labs' business, the activity that they are starting to see in the IoT industry, and also generally manufacturing, and maybe some of the read across. So Rob, maybe welcome first of all, and maybe let's start with a little bit more of an explanation of your business and your company and how you operate around the world.
Sure, thanks. Appreciate that, Chris. So Proto Labs is a contract manufacturer, and we make parts in either metal or plastic through a variety of different manufacturing processes, including injection molding, CNC machining, and additive manufacturing or 3D printing. And we do that across a range of materials in metal and plastic. We also specialize in being very fast, so we can make parts, including injection molded parts, in as little as one business day from the time that we get the design from the customer. And so basically, Proto Labs as a contract manufacturer, what's unique about us is that we've automated the front end of the manufacturing process with software, and that's allowed us to be low cost of entry as well as very fast. And so as a result, we can do quantity one in as little as one day across this broad range of manufacturing processes. The other piece that I just want to highlight is that we are entirely web-enabled, so the customer works with us over the web, sends us their CAD file, and from that we're able to manufacture the part and ship them the part directly.
Okay, so that's great. So I've watched Proto Labs business over quite a few years now, and I mean it's been evolving. As I mentioned, you're worldwide. You've got locations all over the place. You know, I grew up in manufacturing, so I'm very familiar with CNC machining, with injection molding, particularly plastics and silicon rubber.
Sure.
When I started playing with stereolithography, you know, it was a $250,000 investment. It took up a large room, and it was a very big deal and a big scale and commitment. You know, these days you're talking about a Kickstarter option for $300, which I've got at home, and it creates a lot of nice molten modern art. Some of which is really great, and I hasten to add that's the fault of the user and the programmer, not the machine. But it changed the barrier to entry, and it changed the way I started to think about manufacturing. And I think for IoT, that's kind of important. You know, are you starting to see a change in not just the type of company and customer, but the type of things they're using it for?
Yeah, so absolutely we are, and you know, we serve customers across all industries, medical, aerospace, automotive, industrial products, consumer products, electronics, and we also serve customers that range in size from a lot of entrepreneurs, individuals working out of their home, all the way up to Fortune 500 companies. And across the board, we're seeing that people are starting to use these technologies in different ways. And I think that there's a number of mega trends that are kind of supporting that. In addition to access to this technology coming down in cost, there are other drivers that are forcing some of that, right? We're seeing more local manufacturing taking place. We're
Right.
seeing, you know, and Internet of Things, I think, drives a lot of shortening product lifetimes, because now all of a sudden the lifetime of the electronic component of the product tends to drive the useful life of the product.
Yeah, it's kind of driving a built-in obsolescence, right?
Right. Well, my analog watch, I've had for 10 years and I'll probably have for 10 more. But if that's a smartwatch, I doubt I'll keep that for 20 years, right? It'll probably be obsolete in 2. And so that's driven, I think, more customization. In many industries, lower quantities per SKU because of greater SKU proliferation to create that customization, and with those shortened product lifetimes, it's forced a greater pressure around innovation and around kind of moving quickly and also getting products to market quickly. That's always been important, but I think we're seeing an even greater presence in that. And you asked about kind of the regional variations with that. I think those things are true. We're seeing those same megatrends in every region where we operate.
Right.
As you mentioned, we operate in the U.S. and in Europe and in Japan. What does vary is to what extent those different trends impact each industry. And so we are seeing some regional variability in that because, in some of our regions, certain industries are bigger. For example, automotive is bigger for us in Europe, and electronics is bigger in Japan.
So as you're comparing your business around the world, are you starting to see, as I'd imagine you would, the crossover between not just manufacturing choices, but also design trends that you're starting to see spill over into IoT? Because what we've seen and what we've been exploring over the last few weeks in these programs is the fact that IoT really does mean the Internet of Everything, which was the expression that Cisco coined. But truthfully, right, that makes for a hell of a mess in the industry, because now everybody has to understand enough about wireless and enough about wirelessly connected devices to have that as a component of their business. Surely this means that you must have a big education aspect on your hands now as you're starting to talk to some of these companies.
Yeah, we certainly can, and I think one of the challenges with IoT kinds of devices is that they really are very broad, right? They're multidisciplinary, they're cross-functional, they have they're complex products, right, that merge many disciplines. And so you've got people that used to be designing circuits who are now, having to do more physical product manufacturing, and vice versa. And so there is education that's necessary as part of that. And that's actually a place where I think Proto Labs does very well, because we are, first of all, we're easy to find. The manufacturing landscape, I think, can be difficult to navigate.
Right.
And particularly, I think that's true even for, larger companies, but I think it's particularly true for smaller companies, startups, and individuals. We're very easy to find. We work entirely online. And in addition, the way we offer our quotes is through the internet and through an interactive interface on the internet. So basically, when I talked earlier about how we automated the front end of the manufacturing process, what that means is that when we get a 3D CAD file from a customer, we actually apply software algorithms to that, and essentially we calculate everything that we're going to have to do to manufacture that part before we even quote that to them. Mm-hmm. And we turn our quotes around in a matter of minutes to a matter of a few hours. But that's all calculated on a large kind of parallel computing cluster. And so we actually virtually manufacture the part before we quote it to the customer.
So I imagine that dramatically improves your quote accuracy as well as contributes to your turnaround.
Right. So that allows us to, exactly. So that allows us to ensure that the quote is right, and it's not a budgetary quote or a rough estimate. That's a commitment, that quote that comes back. But more than that, because we were able to virtually manufacture the part, we actually calculate like what's called the G code, which is basically the milling instructions that would be necessary to make that part if we were to mill it. So we not only are accurate, but we can actually create a 3D rendering of the finished part. And in fact, we do. We do this online with every quote we send for free. Right. So you can see a 3D rendering of your finished part, and we can then compare that to the source CAD file. And if there are any places where there's a difference because of the manufacturability of your design, right, we can highlight that for you. And so in a custom way, and we do thousands of these a day, we can provide the engineer who's working with us to develop their prototype or their finished part, that kind of design feedback, so that even if it's a manufacturing process that's new to them, and we support about 9 manufacturing processes. We support multiple molding processes, both in plastics, thermoplastics. You mentioned liquid silicone rubber. We support that. Mm-hmm. We also mold metals, stainless steel, and magnesium today.
So is that molding as well as things like sintering, or is that what are those processes?
Yeah, so what I just described was just in molding, but absolutely. So we can make metals, we can mold metals, okay, we can machine metals, and we can sinter metals. Okay. And so, for example, if you, stainless steel, we do in all 3 of those processes. So you might be starting to prototype a part that we would do through a 3D printing by a DMLS or a sintering process. And then as you move from that to higher volume, you might want to machine that part, because you're doing hundreds. And then you might move to a molding process because you want to do thousands or tens of thousands or more. And we can, across most plastic families and most metals, we can actually do that across all 3 of those service offerings. And that allows us to kind of grow with the product or as it scales. But it also lets us be a little bit agnostic to what the manufacturing process is, because of course, each process has some different nuances and some different design constraints. They're better for some, a certain part is, maybe lends itself to one process versus another, and so we can actually be consultative with the customer and explain to them those trade-offs, so that they can pick the process that's right for them, for the needs they have.
Well, so what's great, I like that a lot. I mean, one of the challenges is as smaller companies don't have the teams or the expertise or maybe their own manufacturing engineering group that will help them figure out that type of transition. And one of the things I've seen with IoT is that, many of the smaller companies or many companies that have not been involved in these processes, they get a big surprise when they go from a rapid prototype of some description through to manufacturing. And unfortunately, that's the costly bit, because when you're talking hardware, physical hardware, then you start talking about physically very expensive tooling. And if you make the wrong decision at that stage, it's a very time and cost sensitive issue. So, helping companies like that, I think that's a big deal.
Yeah, there's 2 things that we do to help in that specific area. One is, I mentioned trying to be low cost of entry. So our molds start at $1,500.
Right.
Which is, much, much lower than, most tools are $30, $50, $60, $100,000.
Absolutely.
So, because we've automated all of the kind of the front end of the manufacturing process, so the non-recurring engineering expense that normally exists in the setup, the design of the mold, or all of those aspects, we've essentially taken out. Mm-hmm. And because we're able to act quickly, we can be low cost of entry, so that you can try your design in a mold quite inexpensively relative to any other molding option. But in addition, because we can do that design for manufacturability for the 3D printed part, or for the machine part, or for the molded part, and we can do those kind of simultaneously at a high level of scale, when we talk to the customer, we can understand from them, where they are today in their process and where they ultimately want to go. And if the economics of their production are going to drive them to do molding, even though they might today be just asking us for, let's say, a 3D printed plastic part because they're in a prototyping stage, as you pointed out, the design constraints are different by manufacturing process.
Right.
And sometimes people get into trouble with this because, what you love about 3D printing is that you can more or less make anything. And that's true. However, you can't make anything that's molded, right?
Right.
And if you don't factor in the constraints of molding when you're prototyping, even if you're prototyping in some other process that's only a proxy of what your final part is going to be made in, then you can get caught. So, you take this prototype that worked as a prototype in a different process that you used to prototype it, and then when you want to actually go to manufacturing, you get this aha that I can't scale up with the design that I had. And so the way we address that is that we'll actually quote in all three of the services, so they get the design for manufacturability feedback. And then even if they just want to start with a 3D printed part, which we're happy to do, we'll design, the design for the part anticipates the DFM or the manufacturability of the molded part. Right. And so then that prototype will be a much better proxy of the finished, final higher volume part than would otherwise be the case.
Okay, that's great. I mean, that takes a big chunk out of the front end of a lot of these experimentation projects, because, as I said earlier, one of the challenges that I'm seeing around the industry is a lot of people are deciding to build a hardware device, a wireless device, in order to contribute to the IoT landscape, when they really don't have the starting point or the team in-house to do that. So maybe changing tacks a little bit. One of the things, so we were sitting at dinner the other night, and one of my daughters raised the fact that in one of her classes, she'd been talking with a teacher about 3D printing. And this was a topic because we've now got this bright orange box that sits on our cabinet that's making things well sometimes, if I've got the settings correctly. And I bought that deliberately to make them aware of this and think about manufacturing in the same way that we thought about printing when the first inkjet and laser printers started showing up in the home. One of the comments made was regarding localized manufacturing. So they were highlighting a comment that their teacher had made about things like being able to print prosthetic limbs in certain countries, developing countries, that really wouldn't have the ability to customize and personalize these tools for people in that way if it wasn't done locally. I'm starting to hear some of this regarding things like aerospace spare parts. But what are you seeing in the customers you're talking to regarding the localization of not just prototypes but production? And what do you think is going to do to the whole manufacturing landscape and the kind of the power shift that we're starting to see at the moment with the Chinese economy, for example?
So I think that what you describe is very real. I mean, you talked about it at a few different levels, right? The home 3D printer versus the industrial applications of that same technology for both prototyping and production. I think the home user is a different market and a different application. But I think in terms of the industrial users, I think that's real, and I think it's absolutely on its way that we are seeing more localization and the use of all of these technologies, 3D printing as well as traditional manufacturing processes, like the others that I've described, that are being done more locally because the cost benefits of going overseas, right, are becoming less and less for some of the reasons that I talked about, where we're seeing more customization, generally lower runs of products, and so the economies the economies of scale are a little bit less crucial, and the ability to be flexible and iterate your designs is becoming more important.
Yes.
And so having the production then done closer to where the design and the prototyping and the research is happening is becoming more important, right? Because you think about the old model, it's we do the research and we do the design, and then we lock everything in, and then we wait 3-4 months for the tooling to be made overseas.
Exactly.
And then
you cross your fingers until they're numb.
Right. And then, exactly. And then you hope everything works, and then you produce the parts, and then you put them on a ship, and you wait 6 weeks for them to come back to you. And
Right.
so we're talking about months and months, a half a year, right, can easily go by in that process. And what that means is that from the time you completed the design, let alone started the design, but finalized the design to the time you have really first parts in hand, can be 4 to 6 months. And that only works in an environment where you're getting tremendous economies of scale from all of that. And furthermore, that nothing is changing in the marketplace in the meantime. So in other words, in that 6-month period, the design that's 6 months old is just as good, as what it would be if you were to design it today. And I think that's becoming less and less true all over the place.
Right.
And so, one of the ways that we're seeing that is when we started. So the company's name is Proto Labs. So prototyping is literally, part of our DNA. It's in our name. And when we started, that's really where customers were using us. They were using us for prototyping. And then over time, that expanded to prototyping and, let's say, bridge tooling to address this issue, starting to get parts, from us, but again, locking in the design, but at least getting to market with parts that we could produce for them quickly while they waited for the production tool to be ready, so that that cut their time to market. But now we're starting to see them use us in very different ways. Use us as a on-demand manufacturer,
Mm-hmm.
So that they don't have to store inventory, and just use us as the demand comes in. And also in other applications like end of life, which are coming more and more often and faster nowadays. And so as these I think these underlying forces have caused this change, we're seeing people want to engage with manufacturing in different ways than they used to. And a big part of that is about bringing the manufacturing to be more integral with design, so that they can pivot quickly as needed. Another example is customers will use us to do iterative prototyping in ways that we haven't seen 10 years ago. The company is about 16 years old, and so we've seen this as technology has been transforming manufacturing. We've had the advantage of being able to kind of see different phases of that, and that's been one of them where customers will use us to iterate on designs. They'll make a prototype, they'll make a few hundred parts, they'll test that in the market, then they might adjust the design even after very low volumes were made, and try and tune in to better suit the needs of the customer. Or we'll have customers that might like in the medical device space, because they have to go up for these regulatory reviews, and so they want to make sure they have the best product design for a surgical device, say. And those would be situations where they might make 8 molded parts, all of essentially the same for the same end product, and their intention is to pick the best design
Right.
and take that forward. And so they'll make 8 molds simultaneously, and in 10 days they're going to want 200 parts off of each mold so that they can do functional testing and pick the winner. So I think there's a lot of experimentation that's going on right now, and the old model of having the manufacturing be done halfway across the world isn't really well suited for that kind of experimentation.
No, I agree. I mean, we're seeing with IoT, it's changing as we've seen with a lot of IoT in terms of devices, in terms of applications, uh, uh, data analytics, and use cases, and even business models. I mean, it's just changing the whole environment. And I think that the manufacturing of hardware is definitely a huge piece of that, because the old design cycle of everything in the Western world was developed and getting ready to launch in Q4. It used to be typically consumer electronics was announced in Q1 at all the big shows, and then there'd be 6 months of everyone getting ready after these prototypes had already been visible. That model does not work anymore, because it's too. Well, first of all, there isn't the Q4 bubble that there used to be, not as large at least. But also, if you announce something in January and then you don't start shipping it till November, there's 5 other devices out there that are almost identical before you ship. So
Exactly right.
I think that's changing the model. So maybe to leave it there, Rob, if you've got any final thoughts on IoT, and what are your predictions, maybe for a couple seconds, and what are you interested in personally in IoT?
So what I love about IoT, I touched on this a little bit before, but it's truly the interdisciplinary nature of it, and I'm really excited about what that's going to bring, because I think a lot of innovation, if we look back in history, a lot of innovation is driven in these areas where different fields come together and collaborate, right? People are bringing different thought together, and those are always very fruitful for innovation. And so I expect us to see this really take off, and the whole meaning of what computing is to change, and how we interact with devices and in every aspect of life to change. And so I think it's a very exciting time to be in manufacturing and engineering.
That concludes IoT Innovation for this week. I'd like to thank Rob Bodor from Proto Labs for joining me, and look forward to joining you in future weeks. Please let me know if there's any additional guests or speakers that you would like me to interview. Thank you very much.
IoT Innovation is a production of RCR TV. To reach Chris Hare or suggest a show topic for IoT Innovation, you can reach Chris at cbh@ntete.com. To find out more about IoT Innovation and all things wireless, visit rcrwireless.com.